In this video, I'd like to teach you how to name and write acids. First, let's get a definition for an acid. It's any aqueous species that is capable of donating a proton. A proton is a hydrogen cation. It is a hydrogen atom that has lost one electron. And acids are able to donate one or more of these protons to another species. There are several different types of acids. I'll typically be using these terms in class: monoprotic, diprotic, and polyprotic acids. For example, hydrochloric acid, which we probably already used in lab, sulfuric acid, and phosphoric acid. So, step one for naming and writing acids is a bit different than what you've learned in the past 4 videos. You first need to identify the anion suffix of the acid. And the 3 we will encounter are ate, ic, and ide. So let's look at this example here. Notice, or you will begin to notice, as by the definition, that all acids have hydrogens associated with their structure. Remember, those are those hydrogen cations, those protons. The atom has given away one electron. And we want to look at the anion suffix. Well, in this case here, you can recognize this anion as a polyanion called sulfate. So, the polyatomic ion sulfate. And notice my ending here, my suffix. I'm looking at the anion, the negatively charged portion, and the suffix is ate. All right, so that's step 1. And I know that seems a bit convoluted, and I'm going to tell you that many students struggle initially with naming and writing acids, because it is quite different than writing ionic compounds and covalent compounds. Step 2, if the suffix is ate, then the ending in the acid is ic. If the suffix is ate, then the ending of the acid will be ic. So I would jot this down for sure. This shows here we have our ending ate, and you know these polyatomic ions, perchlorate and chlorate, and all acids have this proton associated, and you'll balance them the exact same way we did when naming ionic compounds. You'll look at each hydrogen proton as +1, and then you'll look at the anion, in this case sulfate, which is -2, and you want those charges to neutralize one another or cancel or balance. And I've extensively gone over that in the past 4 videos. So when we add our protons, we have our ending of the acid, ic. And you can see that here. So we have something ic acid. Something ic acid. So the next step is to apply that stem portion for the anion. In this case here, we have sulfur, sulfuric acid. And it takes a little practice, and you'll get used to them. This is one of our 6 strong acids, so by the end of the course, you'll be very familiar with it. Plus, we utilize it often in lab. So we've taken our stem of sulfur, and we first identified the anion suffix as ate. We said ate is ic. Ate is ic. And then our stem word sulfur, and this is sulfuric acid. And in class, you'll struggle through some of these, and you'll see I'm not going to be very particular as long as you're using the right line of logic for naming them. If you mispronounce it, but it's close. That's good enough for me. Here are two more examples with that same suffix ending. And we have perchlorate being the ion. Well, the acid is perchloric acid. Perchloric acid. Here we have chlorate. Well, this is chloric acid. The key, follow these steps. And if it ends in ate, ate is ick. Now, let's look at this particular acid. These are all aqueous, as the definition of an acid is that it is aqueous. And so here, I want you to pause the video and identify the anion suffix. The anion suffix is sulfite, another polyatomic ion, except this time it's ending in ite. And that's important because when the anion suffix ends in ite, we're going to be using the ending of the acid to be aus. Ate is ick, but now ite is aus. Ite is aus. So by following these steps and thinking through these, eventually you will get the hang of naming and writing acids, I assure you. So this is ite, and that means that the ending of the acid ends in the suffix ous and then the word acid. So, aus acid, sulfurous acid, sulfurous acid. Okay? See how I'm kind of modeling that, practicing of saying it until, oh, sulfurous acid. Okay. And that is the correct name for this acid. And this acid is diprotic, which means it has two of the protons. And sulfite has a -2 charge. And so we need two of these hydrogen cations to cancel or neutralize, just like we did in previous units. Okay, so now we've looked at the anion suffix of ate and said it's ick. Now, and we've looked at ite and said it's aus. Okay, all right, I love this in case you can't tell, because that leads me to one of my favorite sayings. Ate is ick and ite is aus. Ate is ick and ite is aus, a little saying that we've done for years in class, and it helps students to remember. Ate is ick, ite is aus. It helps them to remember to look at the anion suffix and to correlate ate with ick being the ending of the acid and ite with aus being the ending of another acid. And we still have one more to go. And that would be identifying a suffix of "ide." If the compound ends in "ide," then the acid, this is a little more complex, will have the prefix hydro followed by that base name, that stem name, followed by ick and acid. Okay? So here you can see we have chloride, and that's ide. That's a chloride anion, an ide, and then we have hydro, and the stem, the base name of the anion, ick acid. In this case here, we would have hydro, and that's chloride, chlorine, chloric acid, hydrochloric acid. All right, let's look at this one here. Start by identifying that base anion suffix. And in this case here, this is bromide. Bromide. It's not bromate, which is a polyatomic ion. It's not bromite. It's bromide, ending with IDE, which means we will have that prefix of hydro, and then the stem of this word, bromine, bromide, ick acid. And I hope by modeling this, it helps you to understand. Like, pause the video again and try to articulate this. This is hydro, and then we have that stem ic acid, and the stem is bromic. Hydrobromic acid is the name of this acid here, which is monoprotic because it has one proton associated with its structure. All right, now we're getting somewhere. We've looked at eit is ich, eit is ich, and eit is aus, and eit is ich, eit is aus, and hydro is hydro blank ich, which is ide. And I'm just messing with you guys. You probably didn't understand what I'm saying, but I'm having fun saying it anyways. Here are the 3 anion suffixes you need: ide, ate, and ic. If it ends in ide, you will use hydro and then that base, that stem portion, ic acid. If it's ate, it's going to be ic acid. If it's ite, it's going to be aus acid. Okay, so a couple more to look at here. The more practice you get, the better. And in case you haven't noticed, there's a lot of practice for all of nomenclature associated with this unit. So if you work through most of those problems, you will be very proficient by the time you get through watching this video and practicing that portion of naming and writing acids. So here we have the name, and I'm going to underline. We have hydroic acid. That means whatever this is, it ends in ide, and it's iodine, well, look at the periodic table. This is iodide, iodide. Okay, so iodide has a -1 charge, +1, +2, +3, skip, -3, -2, -1, zip. And the halogens have a -1 charge because they've gained 1 electron. So, using that information, we have our proton, our hydrogen cation, H+, and we have the iodide anion, I -1. Remember, we don't show the 1. And if we look at doing our balancing, it's very simple. We have hydrogen and an iodine together in an aqueous hydroiodic acid. Hydroiodic acid. Let's do another one. Whoa, carbonic acid. I'm going to underline this ending of the acid. Ic. Ate is ic. Ate is ic. Whoa. Carbonate. Carbonate, one of your polyatomic ions. Ate is ic. So carbonate has a charge of 2-, which means we're going to need not 1 proton, but 2 protons to balance those charges off there. So these 2 positives would balance out those 2 negatives. So we're going to have a diprotic acid here. And the correct formula is shown on your screen. In an aqueous environment, H2 subscript, CO3 subscript. This is carbonic acid. Now, let's look at a couple more before we call it good. Now let's go from formula to actually naming it. Step 1, identify that suffix, that anion suffix. That looks familiar. That's iodate, one of the polyatomic ions you're required to know. IO3 charge -1. Iodate, 8 is ic. Okay, so I know it's going to be something ic acid. And my stem or base for this, iodate, this is iodic acid. And that's the correct name for that formula. Let's do another one. Nitrous acid. Nitrous acid. Okay. Eit is ic, eit is aus. Eit is aus. All right. So I'm looking for something that ends in ite. And I know a polyatomic ion named nitrite. And nitrite is NO2 minus 1. Nitrite minus 1. How many protons would it take to balance? 1. So this is a monoprotic acid. And this is the correct formula for nitrous acid, HNO2. So we have gotten through all of the nomenclature. You now know how to name ionic compounds both with fixed and multiple oxidation states. You know how to name covalent compounds, and now you even know how to name acids. I'll see you guys in class.